So welcome to this latest video on 162 Maths, and in this video we're going over the AS Maths past paper of June 2024, paper 2, section B, which is the statistics section. Now a little reminder before we get started that in the description I'll include a question breakdown so you can see which question refers to which topic, and I'll also include a link to the 162 Maths contents page which gives you easy access to all the exam paper walkthroughs along with AS and A2 video lessons. So let's get started. So question 11 says the table below shows the daily salt intake in X grams and the daily vitamin C intake in Y milligrams for a group of 10 adults. And it says the scatter diagram of the data is shown below. And it says one of the adults is an outlier. Identify the letter of the adult that is an outlier. We need to circle the correct answer. So looking at the scatter diagram, I can see this one is the one that's most likely to be our outlier. And looking at the table, that's represented as B. So I just need to put a circle around B. Then for question 12, it says which of the following is not a measure of spread? And it says circle our answer, and the one you want to circle here is the median. Moving on to question 13, it says that a head teacher of a school wishes to collect the opinions of students on a new timetable structure. To do this, a random sample of a size 50, as stratified by year group, will be selected. The school has a total of 720 students. The number of students in each of the year groups at the school is shown below. And for part A, it's asking us to find the number of students from each year group that should be selected in the stratified sample. So for this, we're looking at a stratified sample, and we're looking for a sample size of 50, and the total is 720. So for this, all I need to do is first of all take each year group. So I've got year 10 and there are 200 students, so that's going to be 200 divided by 720, and we multiply that by, so that's the proportion, and we multiply that by the sample size required. So all I need to do is type that into my calculator, so 200 over 720 multiplied by 50, and that gives me an answer of 13.9. which you can round up as being 14. Then I do the same for year 11, and that's going to be 240 divided by 720 multiplied by 50, and I type that into my calculator and I get 16.7, which is approximately 17. Then for year 12, I'm going to do 150 over 720. Now I'd always include the working out for this. It's worth 3 marks, so doing it this way shouldn't take you more than 3 minutes to do, and that gives me 10.4, which is approximately 10. And then year 13 is 130 over 720 multiplied by 50, which gives me an answer of 9. And so all you want to do here is then just double check to make sure that all of those numbers add up to 50. So if I add 14, 17, 10 and 9, just to double check, you're rounding, and that does give me an answer of 50, so that's good enough. Then moving on to B, it says state one advantage of using a stratified sample. Now for this, hopefully you would know the advantage and disadvantage of each of the sampling methods that you need to know for statistics on the AS course, but a very common answer I would say for a stratified sample is something along the lines of that it ensures each group is represented in the sample. So something along those lines would be absolutely fine. There are many other answers, so you might want to check with the mark scheme to see if you do get that single mark. Moving on to question 14, it says that discrete random variables x and y can be modelled by these distributions, and it says given that the mean of x is equal to the variance of y, find the value of p. So for this, the first thing we need to do is recognise that the mean is equal to np and the variance is equal to np, and it's 1 minus p. So there's the formulas that you need to know. So the mean of x is equal to 40p, and the variance of y is going to be equal to 25 multiplied by 0.6 multiplied by 0.4, which gives me an answer of 6. So what do we know? Well, we then know that 40p is equal to 6. I then make p the subject, so 60 over 40, which simplifies to give me 3 over 20. So there's my value of p. Then for b, it says find the value of y. So then from this, we can then use the parameters of working this out. So if I go back to y, I've got just write down the parameters, which were 25 and 0.6. And so you can use your calculator for this. So to use your calculator, most of you should have the Casio cal. So if you go to distribution, binomial PD, so you want binomial PD, and then you want variable, then select variable, and then for your parameters you want to select x equals 17, n equals 25, and p equals 0.6. Then entering that into your calculator, so I'll just do that now, 17, 25, 0.6, and typing that straight into my calculator, I get a decimal answer of 0.11997997 blah blah blah. And then you might want to round this up to 0. And it's going to be, well, 0.1222 decimal places. And I would always recommend that if you are going to give a rounded answer, always state what you've rounded it up to. Then for question 15, it says the number of flowers which grow on a certain type of plant can be modelled by a discrete random variable x. The probability distribution of x is given in the table below, and the first part is asking me to find the value of p. So for a discrete random variable distribution is what we've got here. What we need to recognise is that one of the key properties is that all of these probabilities need to add up to 1. So what that means then is 0.03 plus 0.15 plus 0.22 plus 0.31 plus 0.09 plus p, all equal to 1. So if I add this all up, in which I'll just do that on my calculator now, 0.03 plus 0.15 plus 22 plus, I get 0.8 plus p equals 1, so therefore p is going to equal 0.2. Then for b, it says 2 plants of this type are randomly selected from a large sample, a batch size received from a local garden centre. Find the probability that 2 plants will produce a total of 3 flowers. Now for this, because 2 are being selected, what we've got is we need to look at the possible combinations in which we can get 3. So we can get 3 by having 0 and 3. So that's one possible way. We can get 3 by doing 1 and 2. We can get 2 and 1. And we can also get 3 and 0. And I think they're the only combinations out of 2 that we can get exactly 3. So what we then need to do is work out the probability of each of these. So getting 0 and 3 is 0.03 multiplied by 3, which is 0.31, and that's going to give me an answer of 0.0093. And then 1 and 2 is 0.15 plus multiplied rather 0.22. So 0.15 multiplied by 0.22 gives me an answer of 0.033. Then 2 and 1 is 0.22 multiplied by 0.15, which is going to give me the same. Oh, let me just correct that. And 3 and 0, which is going to be 0.31 times 0.03, and that gives me that, and adding them all up I should get an answer of 0.0846. Then moving on to question C, it says state one assumption necessary for the calculation in part B to be valid. So for this, again, there's a number of answers you can write for this and for part 2. So again, if yours doesn't quite falls in line with what I've written, then just check the mark scheme to see if it'll be accepted. So for this one, I would say that the number of plants, flowers rather, that can grow. Oh, what's happened there? That can grow on a plant. And again, one of the most common answers for these is always that it's independent. Is independent from of the number that grow on another plant. So don't just say that it's independent, you've really got to put some context behind it. On another plant. And then comment on whether in reality the assumption is likely to be valid. Now for this you can either agree or disagree in terms of whether this is going to be likely or not. Again, looking at the mark scheme, there's lots of different answers you can possibly give. It just needs to be a valid answer. So for this, I would suggest that something along the lines of that the plant grows in the identical, or should I say in identical conditions, not in the, so in identical conditions as all the other plants. Now, how likely is that to happen? Again, it needs to be in the exact, you might have, depending on the size of the sample of plants that you've got, you might find that one sees more sunlight than the other. One may get more rainfall or more water than another. And in order to be valid, it needs to be exact, precise conditions for all the plants for it to be a fair and unbiased test. So something along those lines is it possible to grow 2 plants in the exact, or a vast amount of plants in the most identical set of conditions? Again, which may be unlikely. Now, if it was a couple of plants, you think fair enough, but again, it might find like an insect or a sort of animal may have attacked one plant, or may have, I don't know what they do to plants, but it may have done something to it. So you just want to be mindful of that and see how realistic it is. But again, like I said, if you're not sure about whether your answer is correct, just check the mark scheme to see if it is valid. Now, moving on to question 16, it says an investigation into the hydrocarbon emissions from cars in the large dataset was carried out. The results are summarized below. It says when n is the total number of cars which had a measured hydrocarbon emissions in the large dataset. And question AI is asking us to find the mean of x. Well, to find the mean of x, what I need to do is the sum of x over n. So for this, all I need to do is 128.657 divided by 2405. I type that into my calculator. And it gives me an answer of, I just made a mistake, so just bear with me. Gives me an answer of 0.0535, and that's 3 significant figures. It then says find the standard deviation of x. So for this, what the formula I need to use is sigma x squared divided by n minus the mean squared, and that's all square rooted. So using the values from the table, I get 8.701707 divided by 2405 minus 0.0535 squared, all square rooted. And if I type that all into my calculator, again, what you may want to do is, if you've still got the exact value of the mean, maybe use that to see, so you don't lose any rounding issues. Divided by 2405 minus ans squared. And I get an exact answer of 0.02750 blah blah blah, which to 3 significant figures rounds to 0.0275, and that's to 3SF. Then moving on to question B, it says a large data set is a sample taken from the entire UK Department of Transport Stock Vehicle database. It is claimed that the values in Part AI and Part AII obtained from the large data set should be reliable estimates for the mean and the standard deviation of the hydrocarbon emissions for the entire UK Department of Stock Vehicle database. State with a reason whether this claim is likely to be correct. So for this, what you want to say is something in the lines of that and this is just quoted from the mark scheme, that the large data set does not include cars from every region of the UK, so the claim may be incorrect. And again, for one single mark, I'm not a big fan of these large data set questions. It is usually one of these guesses that you then may need to make, but for one mark, can you afford it? I'll leave that one up to you. Then for II, it says state one type of emissions where more than 80% of the data is known for the car in the entire UK Department of Transport Stock Vehicle database. Again, just need to state either you can go for CO2 or CO or NOx. Any of those three will be good enough for the single mark. It then says to the last question, it says the proportion of vegans in a city is thought to be 8%. The owner of let's recall that one again. And moving on to our last question, it says question 17 is the proportion of vegans in a city is thought to be 8%. The owner of an organic food cafe in this city believes that the proportion of their customers who are vegan is greater than 8%. To test this belief, a random sample of 50 customers at the cafe were interviewed, and it's found that 7 of them were vegan. Investigate at a 5% significant level whether the sample supports the owner's belief. So let's have a look at the key bits of information of this hypothesis test. So the first thing I notice is that we're looking for a proportion that's greater than 8%. We know that the sample size or the test statistic is 7 out of 50, and we're testing at a 5% sig level. So for this, what we need to state is the HO is that P is equal to 0.8, and the null hypothesis is that P is greater than 0.08. So we're looking at a one-tail test at a 5% sig level, and we're looking at a binomial distribution with the parameters being 50 and 0.08. So from this, what we then need to do is we then need to find the test statistic, which is find that x is greater or equal to 7. So using my calculator, I can work out this. So we're looking for 1 minus the probability that x is less or equal to 6. So going into BCD, we're looking at variable again. We're looking for an n value of 50, a x value of 6, and a p value of 0.8. And I do 1 minus 0.898128, which gives me an answer of 0.102. So to conclude, all we need to then say, so as 0.102 is greater than 0.08, we accept HO, or you could say you do not reject HO, and there is insufficient evidence at a 5% sig level to suggest that the proportion of vegan customers is greater than 8%. So something along those lines would be absolutely fine. And there we go.